Hello, everybody. What is up with this weather? You guys with me on that? It is like freezing outside and it's May, and that is the pits. Okay, hey, today you guys shouldn't have learned anything new. There was no video, but just some 4 problems for you guys to practice with law of sines. The most requested problem was number 8, so we're going to take a look at that one here first. Let me just reference for you guys that when you are given like the 3 pieces of information, you have to draw a picture. It does not need to be drawn to scale. Clearly what I'm drawing right now is not drawn to scale at all. But you need to draw a picture. You need to add onto that picture the pieces of information that you are given in the problem, and then as you reveal and find like the other missing angles and the other missing side, you then need to add those pieces of information as well onto the picture, please. Okay, so we're going to start out looking for a strong ratio. That would be where we would know an angle, and we also would definitely know the side opposite that angle. Looks like we know angle A and side A, so I'm going to set up with that. Okay, I do not know angle C, nor do I know side C, so I would want to steer clear from that for right now, because I don't want to create in this other fraction 2 variables that I do not know. But I do know side B, and I could use that to help me find then angle B, okay? So I'm going to set this up sine angle B and put that over side B, okay? Then we're going to cross multiply, okay? So when we cross multiply here, we end up with 12 sine of 95 equals 19 sine of B. Okay, I'm going to get rid of the 19. Okay, now at this point, this is not angle B yet, because you'll notice there is still a trig function attached right here to angle B. Okay, when you are solving for angles, the only way to remove a trig function from its angle is to do the inverse trig function, in this case the inverse sine, over here on this right side. That will knock off the sine and leave you with just angle B. Of course, we know we have to do the same thing to this side. So I know this looks really complicated maybe to kind of type into your calculator, but you're going to want to type in inverse sine. Okay, again, you want to be in degree mode for sure, and then you're going to type in 12 sine 95, close up those parentheses, and divide by 19. So you got to be really careful with your parentheses with these. Okay, this should give you that angle B, you'll see on your calculator, it's like 38.99. You're going to round your angles up, though, to the nearest degree. Okay, so as you find that, I'm going to change the color on this because this is something I'm adding that I found. Angle B is 39 degrees, okay? Now, before you proceed with finding any of the other parts to this triangle, what you need to do is you need to assume that there may be a second triangle with obviously the same 3 given pieces of information. So I'm drawing this second triangle. I'm right now just putting on the given information from the problem, and here's the key. That very first angle you found for angle B, and you, by the way, had no choice but to find angle B as your first step for this problem. Angle B, if there is a second triangle, angle B in the second triangle is always supplementary to angle B in the first triangle. Okay, supplementary means the 2 angles add up to be 180. So if I take the 39 degrees and subtract it from 180, that means if a second triangle exists, angle B would be 141 degrees. Now, how do we know whether the second triangle exists? Well, here's what we know about triangles. The 3 angles in a triangle have to all add up to 180 degrees. Now look at this. If I add up 95 and 141, those 2 angles add up to 236 degrees. That is well over the 180 degrees that is allocated for a triangle, and I haven't even accounted for what angle C should be. So that tells me that I know that there is definitely not a second triangle. I also know that there's not no triangles possible. Otherwise, if there were 0 triangles possible, when I typed this part right here into the calculator, I would have gotten an error instead of 39 degrees for angle B. Okay, so that tells me I'm going to stick with this first angle. I'm sorry, this first triangle rather, and I'm going to keep moving forward, just solving. There's only going to be one triangle, and I'm just going to solve for all the remaining pieces. Okay, now remember, we knew nothing about angle C or side C, but once we filled in angle B here, we could certainly subtract off the other two angles that we know in this triangle, and that will give us what should be left here for angle C, which would be 46 degrees. Again, just see how I'm kind of adding these things onto the picture. Okay, now to get side C, I'm going to go back to the strong ratio, sine of 95 over 19. I'm going to set that equal to sine of 46, because that's angle C, and I'm going to put that over side C, lowercase c. Okay, this is the last piece that I have to solve for. Okay, so I am cross multiplying. Okay, now this one's a little different because I'm not solving for an angle, I'm solving for a side. So I can go ahead and divide by sine of 95 degrees, and that will leave me with this lowercase c by itself. So I'm going to type into the calculator 19 times sine of 46. I'm going to divide that by sine of 95, and we usually carry our side lengths out to 2 places. I'm not sure if the book said 2 places or 1 place here, but I'm going to go ahead and add that. I'll carry it out to 2 here. 13.72 units would be the length of side C. Okay, so here I have all those pieces labeled on the picture, and I'm also just going to make a note that there is one triangle possible. Okay, because it did ask in the directions how many triangles are possible. Okay, so we're going to try one more. Number 9 was the other one that many of you were requesting to see here. Okay, so we're going to start out same way. Just draw a quick triangle, label it ABC. Let's throw onto our picture the given information. Okay, and then we're going to identify, here's our strong ratio. I'm going to set up sine of 60 degrees over 15, and again, I have no choice but to do sine of angle B over 24. Okay, I go ahead and cross multiply. Okay, you kind of get the feel that this is a very similar procedure to the previous question here. Okay, you'll notice we are solving for angle B, and so I am going to be left with needing to do the inverse sine to get that sine to cancel off. So I just have angle B. And so I'm going to do the same thing over here to this side. Now, when I type this, all this right here into the calculator, I'll go ahead and highlight this. When I type this, if I get an actual answer, then I know there is at least one triangle, and I would draw a second triangle and see if that supplementary angle there would make sense for that second triangle to hold 180 degrees. Okay, if I get an error, which is what you should get on this problem, if you attempt to type all of this in, you get an error. That's the calculator's way of telling you there is no way that you could have any degree measurement for angle B with these 3 given kind of pieces of information. So I'm going to go ahead and stop there. I'm going to say there are 0 triangles possible. Okay, and I don't have to proceed with trying to solve that because that's not even, there can be no triangle possible with that. Okay, all right, hopefully that helped you guys, and hope you guys have a great night.